Alright, so the recording has begun. This is day 1, week 18. Again, day 1, week 18 of our journey here together. And it's a delight to have each and every one of you here. How was the day, by the way? How did it go for each and every one of you? How did
Week what?
the day? This is week 18. This week. Week 18, my friend.
Boys.
Yeah, I know that sounds like a big number, right? Yeah, week 18. But how did the day go?
Track.
You did track today?
I said I lose track.
All you do is track. Okay. All right. Yeah, this is week 18, my friend. What past paper we was on? Did we finish the 2020? I don't know if we finished that. Did we even do the 2020? Yeah, we had to do this. Yeah, I remember this. Y'all didn't answer me. How was the week? Sorry, how was the day thus far?
Uh-huh.
The day.
Um,
How did the day go?
it was good, but I had a lot of work. So
Day good, but you had a lot of work. Okay. All right. Anyone else? Give me a sneak peek of the day. How did it go? Don't be shy. Don't wait for someone else. You be the person.
what happened? What happened?
No, I saying I wait on someone else to answer. How was their day? We did all this. We did this. We did this. We did this. We did this. Did we do this? Yeah, we had to, because then we did this. And then we add them. Did we do the deposit thing? No. We did not do this. Oh. Oh, okay, good. Okay, so I know how to start. So we're starting from number 13. That's where we left off. Okay. Anyone? No one want to answer that question? Why are you so shy today?
Daytime.
It was alright.
Hello?
All right. Yeah, I'm asking how was the day?
Good day.
Hey, what you saying? Yeah, I'm asking how did the day go?
It was slow today.
Slow. Okay.
Yeah.
Slow, interesting word.
How was your day, Mr. T?
Fantastic. You know how my days go. Oh, it's fantastic.
Shouldn't ask that.
Say it again. Yeah, my day was fantastic.
I said I shouldn't ask that because I know the answers can be the same.
Yeah, man. I can't have a bad day. But today was exceptionally good though. I ain't gonna lie, today was exceptionally good. So I have no reason.
We had an assembly today, so
Okay, yeah, I know how that's be. That'll be the whole day wasted.
not really.
Or at least the majority of the day, like the first 2 periods.
I had to conduct the
You had to do what?
thingy.
Oh, you was the MC.
Maybe.
Ah, surprise. Of course, man. Yeah.
Bro, Mr. T, I was so excited. When I look up my white belly, all of it was
Yes, that's happened. Alright, so let's get to business. This is number 13. The cash price of a stove is $800. So if you buy it cash, excuse me, if you have enough money to buy it cash, then it's going to be for $800. But they also have a higher purchase plan, and the highest purchase plan says that what you have to do is that you have to put some amount down, like a down payment or deposit, and then after that you're going to pay on it every month. And so it can also be bought on higher purchase by paying a 20% deposit, followed by 12 monthly payments of $75 each. Okay, so calculate the amount of the deposit. Calculate the amount of the deposit. Any ideas for this? What would be the actual amount? What would we do there?
The answers or
How you do it and then the answer.
okay, I said 20 over 100
Yeah,
multiplied 800.
multiply by 8. Very good. How much you get?
I get 160. 160.
Minus 6. Very good. That's a good way to do it. So the amount of deposit, like Juan said, is going to be 20% of the cash price. 20% of the cash price. We know that the cash price is $800, and 20% of that is going to be 20% rather can be written as 20 over 100. So then we multiply the two. We cancel out the zeros, right? So this 0 with that 0, that 0 with that 0, we're left with 20 times 8, 20 times 8. And 20 times 8 is definitely 160. 1 times 1 is simply 1. And so the amount of deposit is $160. Okay, so let's
Can you get a picture of the whole,
the whole thing.
please?
No problem.
Mr. Petit,
Hey,
did you send a recording from Sunday?
no,
Yesterday?
he just asked about it. Let me see how far it is. It's finished. Okay, so it's already uploaded. So I just need to send that to you. That was 4 hours. Wow. It was processing. That's why I didn't send it yet. But I'll send it to you.
What time y'all at?
We start at 5 and end at 9. About 9.
I thought y'all was there from 2.
Nancy them was there from 2 for those who had power.
Oh,
Alright, so $160 is the amount of the deposit. Any questions on this?
no, sir.
Okay, that's good. Alright, so this is how we would write it if we want to write it fully, right? And I wrote it step by step for you here. Now B says we want the total amount of the monthly payments. Now how are we going to figure that out? The total amount of the monthly payments.
Multiply.
Multiply what? Total amount of monthly payments. Multiply what?
Would you multiply the 75 by 12?
Yeah, 75 by 12 because each month she pays $75, or this person or the person on the higher purchase plan must pay $75 each month, and it's 12 months of the year.
I think it's 890.
Say 890. Well, let's see.
Oh no, 900.
Okay. Anyone else want to second that or get a different answer? This is for B. Total amount of monthly payments. Anyone got something?
900.
Okay. Anyone else?
I agree.
Okay. 900. That's going to be 12 times 75, which gives us the 900. Of course, and then let's move on. Now we want the total cost of the stove using the higher purchase plan. Right, so what would be the total cost of the stove using the higher purchase plan? How would we go about doing that one?
What you say?
We want the total cost of the stove using the higher purchase plan. So would that be?
You could go back after the questions. I agree.
We want the total cost of the stove using the higher purchase plan.
Wait, you wouldn't add 160 and next one?
And what?
The one we get for the monthly payments.
Anyone agree? We want the total.
Wait, Nancy typed something in the chat. Nah, yeah, she typed the same thing.
What she type?
She typed 900 plus 160.
900 plus 160. Good.
Yes, sir.
Okay. So the total cost would be the total cost of the stove on the hire purchase plan is going to be the amount of the deposit plus the total monthly payments. Now the amount of the deposit we saw was $160, and we got that because that was 20% of the cash price. And the total monthly payments is going to be $900. So first you have to make a deposit of $160, and then you have to pay $75 every month for 12 months. It's just going to be 900 plus 160, so it's going to be $1,060 if you want to buy this thing on hire purchase. Okay. Do we understand that? Any questions on that? Are we good?
Yes, sir.
Okay.
Good.
All right. Next up is how much would a person save by paying cash? All right. How much would a person save by paying cash?
$260.
$250. How did you get that?
I say 260.
260. How did you get that?
I subtract from the 800, I believe, was in the question. I saw it was 800, but I believe it's.
Mm-hmm.
Um,
With what?
I subtract 800 from the higher purchase, the total cost of the stove using the higher purchase.
Okay. Very good. That's correct. So if you want to know how much money is saved by paying cash, we'd say 1,060. And we want to subtract that with 800 because 800 is the store's cash price. So the money saved by paying cash is going to be equal to total cost of stove on the hire purchase minus the stove's cash price, which is 1,060 minus 800, which is going to be $260. All right, so that's how you do it. All right, so that's how you would answer a hire purchase question. This comes on, this guide come on y'all paper 2, Bgcse people, or paper 1, Bgcse people.
Mr. T, would the Bgcse on be the sample as well? Or do you want
It could be. It could be. Because it's
They'd probably have like an NIV question and then
at the NA. Yeah.
no, I asking probably would.
Yeah, I mean, with higher purchase, they might probably include it where notice that each number here was a whole number. You see that? They was very round and easy. So what they like to do sometimes they like to add like cents to it just because the person would be using a calculator, so it wouldn't be hard to compute that. That's it for basic explaining. Alright, so next one is dealing with basic wage. You know, these type of questions like to come. Hey Lionel, where are you? Are you here?
Yes, sir.
Okay, how you doing?
Good. But I was supposed to tell you something, like from last week, that I lost my phone. I lost my phone, so that's why I haven't been sending you anything.
Okay,
And I can't access my email because I have a two-step verification. I
okay,
mean, if you ask my mom, she could tell you the story.
okay. So, but you're still writing notes and following though.
Yes, sir.
Okay, that's important. All right. So this next one is about Marcosine. So Marcosine works for $12 an hour, And a basic week consists of 40 hours of work. Now you got to be careful because overtime here is paid at double time. Double time. So the question says here, calculate a basic weekly pay.
480.
480. How did you get 480?
The money she get per hour and the 40 hours she don't work for that week.
And what did you do with them too?
I multiply.
Multiply. Any 1 second to answer?
I second it.
Okay, good. Okay, so that's very good. So basic weekly pay is going to be $12 times 40 because she get paid $12 an hour. It's 40 hours that she works, so it's $480 for a 1 week. Now question is, how much is she paid for 1 hour of overtime?
When you double the money she's get paid, I think.
That's, I mean,
24.
$24. Very good, because overtime is paid at double time. Okay, so it's gonna be what?
12 times 2.
12 times 2. Very good. So 1 hour overtime is gonna be $12 times 2, which gives us $24. Okay. Okay. So next up is last week Maxine worked a total of 56 hours. How many hours of overtime did she work?
40 minus 50, 56 minus 40.
Which is
16.
16 hours.
16 hours. So remember, she's supposed to work a basic week of 40 hours, but she worked 46 hours. That's way more than 40. And so it's going to be 56 minus 40, which is going to be 16. So overtime hours of work last week equals hours of overtime work last week minus hours of, no, I read this wrong. Hours, total hours worked. So it's supposed to say total hours work last week minus hours for basic week. It's going to be 56 minus 40. Good. So that's how we have it. Any questions on this? Good.
This question is, these type of questions come a lot.
Yeah, they like to come. They like to come. All right. So how much was her overtime pay?
16 times
384.
16 times what?
24.
24.
Very good. 16 times 24. So it's going to be
380.
16 times 24. I have the little calculations here for you, Miss Cooper.
Sure.
All right, so it's going to be 384. So that's the answer. Okay. Now we know what the final question is, right? What is her total what is her total earnings for the 56 hours work?
You add?
Add what?
Her basic pay and then her overtime pay.
Good.
480 plus 384.
Very good. 480 plus 384. Add them. That's what?
That's 860. Oh, 864.
864? Yes, 864.
Yes, sir.
So at the end of the week, she making $864. Do you excuse Maxine or you think that's too low? What you think?
I need some more money.
Get some more money. Okay. Think it's decent or no?
If I ain't got no churn, yeah.
Am I gonna try? Okay. Alright. Well, I would say that this is what? About 3 times the the minimum wage. So she's making way more than minimum wage in the Bahamas. But she's working a lot of hours too. Yeah, that's 4 times minimum wage, just about. Alright, so she's definitely making more than average Bahamian. Um, yep, at least per week. Okay, that's cool. Okay, so let's move on to the time graph. The graph shows a car. So this is a car that's journeying from Gully to Alan and back. I don't know why they just use regular names. Like, like Beantown and the Yellow Ella, you know what I mean? It's like Gully and Alan, where that is. Anyway, the distance is in kilometers. Alright, so 10 kilometers, 20 kilometers, and so on. I don't want to give the answers right away, so let me find the people. I think this is 2020, so
What's the questions?
yeah, I want to show the question. So this one, let me uh, so that's 2020, right? Paper 2. Oh, that's not 2021, 2020. Paper 2. Okay. Alright, so question A, let me keep it like this. At what time did the journey begin? At what time did the journey begin?
10 a.m.
Say it again.
No.
Oh, no, 9 o'clock.
9 o'clock?
9
Yes, ma'am.
a.m.
9
Yes,
a.m.
sir.
Alright. Because this is 9, that's 10, 11, 12, and whatnot. How
I'm
far?
guessing 9:30 in the middle.
So, yeah, 9 to 8. So, it start right there. So, that's 9 o'clock. 9 a.m. So, how far is Gully to Alan? How far is Gully to Alan? How far, people?
70
Yes, ma'am. 71
kilometers.
kilometers. Yes, ma'am. Good. How long did the car stop in Alan?
For from 12:30. I mean from 11:30 to 12:30, so like an hour.
Yes, ma'am. So this is where it stopped from. Where you see this flat part, this is where it stopped in Alan. So that was at 11:30, and it stopped from 11:30 all the way to 12:30. So it stopped an hour there. How long did the entire journey take? Do not include stops. How long did the entire journey take? Do not include stops. Hello, anyone home?
3.5 hours.
3.5 hours. Someone say 3.5 hours. Anyone else? How long did the journey take? We can't include the stops though.
Yes, sir.
What you say?
Oh, let me do it again.
Lionel, what you think? How long did the journey?
Wait, each of the blocks is 30 minutes, right?
No. Yeah. Each of the block is 30 minutes. That's that would work. Yeah, each of the block is 30 minutes.
Isn't it just 3 hours?
Just 3 hours. Let's see. So we said that the journey began at 9 a.m. One moment. This is gonna stop. I got the recharge data. Give me a moment. So y'all can still hear me? Yeah. Okay. All right. Hello. Hello.
Hello?
Yeah. Can you hear me?
I could hear you now. You were like freeze because I couldn't hear you.
Okay. Yeah. So at what time did the journey begin? We already said it was 9 a.m. How far from Gully to Elan? We already said 7 kilometers. How long did the car stop in Elan? We already said it's an hour. Now we're trying to figure out how long did the journey take, but we not including stops.
3 hours?
It's actually three and a
Bruh.
half hours. Right? And the reason why we get that is because let's look at the entire journey with stops. It starts at 9 and end at what time?
1:30?
1:30. So we start at 9 o'clock. Then we go to 10, that's 1. 11, that's 2. 12, that's 3. Then 1, that's 4. But then you have 30 minutes extra. So the entire journey, including stops, so with stops, is 4 hours and 30 minutes. But we just say that if we include, oh, made a mistaken, because we can't include no stops. So not only did they not stop, not only did they stop here, but they also stopped here for 30 minutes. So yeah, so that means that this is going to be the stop duration was from 11:30 to 12:30, but we also had, I didn't include this one, but there's two stop durations. So this is stop duration 2, and then this is stop, and then we have stop duration 1. So that's my part.
So the answer still remains the same?
No, the answer doesn't remain the same.
Okay.
So the stop duration, the first stop duration was from what? 10:30 to what? 11?
From 10:30 to 11
Yeah, so
o'clock.
10:30 to 11. So that's gonna be from 10:30 to 11 a.m. that's going to be what, 30 minutes?
Yes, sir.
Which is what? Half an hour. And so the entire journey without stops is going to be 4 hours and 30 minutes minus an hour and 30 minutes. So that means that it's actually 3 hours.
Yes.
It's actually 3 hours. He was right, Miss Cooper.
I knew it.
Yeah. So it's 3 hours. Any questions on how we got the 3 hours? Any questions on how we got the 3 hours? Let me know.
Yes, sir.
Okay. So what I did was here, I considered the entire journey, which is 4 hours and 30 minutes. We know that we stopped for 30 minutes and we stopped for an hour. So we got to remove that from the entire journey. So 4 hours and 30 minutes minus an hour and 30 minutes is going to be 3 hours. Okay. So now, they want us to figure out how far did the car travel for the entire journey. Very important. How far did the car travel for the entire journey? How far did the car travel for the entire journey?
What did the question say?
How far did the car travel for the entire journey?
It's 70 kilometers.
70 kilometers. Anyone want to second that?
What about there and back?
Now you're thinking.
I actually. So 140.
140. Very good.
140. I second guess my question.
Yeah. So to Allen is 70 kilometers. From Allen, 70 kilometers. So the distance traveled is going to be what? 70 plus 7 is going to be what? 140.
My brain working tonight.
I noticed. Okay, good. Calculate the average speed for the entire journey. Do not include the stops. Calculate the average speed for the entire journey, but do not include the stops.
Okay. I have an answer, but I should say unless you do it first.
What chances?
Unless it's you. I can wait till you do a suggestion.
Alright. So for this one, I actually did it wrong because remember my thing was wrong. My time was wrong. So I have to change this from 3.5 hours to simply what? 3 hours, right?
Yeah.
And then that's just to be 140 divided by 3. I'm trying to figure out why this is for 3 points though. Anyway. So
I don't know why.
140 divided by 3 is going to be
Where the 3 hours came from again?
the 3 hours came from, remember we said that how long did the entire journey take without the stops?
Okay.
Yeah. So if you look carefully, it's gonna be 30 minutes. 30 minutes. So from 9 to 10, that's an hour. Then from 10 to 9:30, that's an hour and 30 minutes. Right? From basically from 9 to 10:30, that's an hour and 30 minutes. And then we gotta skip this because this is a rest. We can't include this. Then we get another hour So then we get another 30 minutes here, which makes it 2 hours. And then we get from 12 to 1:30. Sorry, from 12:30 to 1:30, that makes it 3 hours. So all in all, it's 3 hours that the journey took. Now, the entire journey, now if we want the average speed, is going to be 140 divided by 3, which is what?
47.
47, not quite 47.
And this is to the nearest whole number.
They said give answer back now, so I'm okay, good. That's correct then, 47. 47 what?
Kilometers per hour.
Kilometers per hour.
You can scroll us. I could take a screenshot.
No problem. And this is 2. Okay, good. So from where? The where should I from where, Miss Cooper?
Huh?
From where? From where should I start?
Right here. I think you go up again. I think I get a screenshot of that, but I show. Okay.
We good? Alright, so that's that. Next up is number 16. So write an expression for each of the following. Patrick thinks of a number, x. Sorry, Patrice rather. Thinks of a number, x. She multiplies it by 4, then subtracts 3. So write an expression for that. Say it again.
4x minus 3.
4x minus 3. Do we have anyone to second that? Do we have anyone to second that?
What she say?
X times 4 minus 3.
X times 4 minus 3.
I said 4x minus 3.
She said 4x minus 3.
Okay.
I'll second it.
Second that. Okay.
Mm-hmm.
So thinks of a number, multiplies it by thinks of a number called x, multiply it by 4, and subtract 3. That's definitely going to be 4x minus 3. Good. Angelo thinks of the same number. He multiplies it by 2, then subtracts by 7. So what is that going to be?
2x minus
Would it
7.
be 2x minus 7?
Yes, ma'am. 2x minus 7. Very good. 1 and Cooper. All right, now the two expressions are equal. Form an equation to show this. So what equation?
4x minus 3 equals 2x minus 7.
I agree.
You agree? Yeah, that's correct. 4x minus 3 equals to 2x minus 7. Now, the moment of truth, solve your equation to find the value of x.
Give me a second.
You could just carry over the.
Actually do it and tell me the result. Let's see if we are algebra geniuses in here.
I have some. I done. X equal to 5.
Who said that? X equals to 5?
Pinocchio.
Say x equal to 5. Anyone want to section that?
-2.
You got negative 2. Anyone seconding negative 2 or 5?
Oh,
I got 5. Positive 5.
-2.
Alright, so which is it? Is it negative 2 or 5? So let's see.
-2.
Okay, so let's see. Notice that the first thing we're going to do is send the 2x over. So when we send the 2x over the equal sign, it was positive, so we're going to change it to a negative. And then this 3, negative 3, we're going to send it over the equal sign as well. And because it was negative, it's going to become positive. So that's the first step. Then we know that 4x minus 2x is what?
2x.
2x, very good. And negative 7 plus 3 is what?
Negative 4.
-4.
Alright, so after that, we want to divide both sides by 2. So we divide this side by 2, divide that side by 2. So we are left with x is equal to negative 2. So are we good?
Oh, yeah, it should.
No problem. So the answer is negative 2.
Good.
Okay, so let's continue. So Mr. Green bought the following items from the food store. Calculate his total bill. Oh, okay. Let me not give away the answer here. Um, so five apples at $1.09 each. 8 oranges, 2 for 99 cents, and 1 watermelon, $15 each. I want you to calculate each of them and tell me the total. Okay, so do that for me, please. Are we good? We done? We done?
I have the total. I done.
Okay. Okay, what's your total?
2513.
2513. Anyone second in that or get out a different answer? Hello, anyone want to second that or get a different answer? Hello? I asked if anyone want to second it or got a different answer.
What was the answer?
Say it again.
What was the answer?
What was your answer?
2513.
2513.
She said 13.
I'm 25.4.
Or 25.4.
25.4.
25.4. Alright, so let's check and see. So we know that each apple is for $1.09 each, and so we have 5 apples, and so that's gonna be 5 times 1.09, and we'll get 5.45. You could easily check here 5 times 109 is 5.45.
I do though, but I get a different answer.
And then we have 8 oranges. 2 is for 99 cents. Alright. Oh, I did it wrong. Why did I do 9.8? See my mistake? I realized I didn't account for the 8 oranges. 2 is for 99 cents, but we have 8 of them. And so are supposed to be 8 oranges, so it's gonna be 1, 2,
I get 25.4 now. I don't know how.
6, 7, and 8. It's 8 oranges, so this 2 is gonna be for 99 cents. Right? This 2 is gonna be for 99 cents. This 2 is gonna be for 99 cents. And this 2 is gonna be for 99 cents. And so what should we multiply 99 by?
4.
4. So not 2, like how I did that. So let's change that. So it's gonna be 4 times 99 cents, which is what?
3.96.
3.96. Okay, good. And then one watermelon, it costs $15.99 each, so that's gonna be $15.99 because you only get one. So if we add these 3 together, that's 5.45 plus 3.96 plus 15.99. The answer is 25.40 cents. Anyone got that before?
I get that the second time I do it after I heard so many different answers. But I just put 25.4.
$25.40.
What if I just put 25.4?
Well, it's still a work. But do it in terms of like money. Alright, so that brings us to the end of this people. That's a good thing. I think that's it. Where are we? Yeah, I think that's it. Oh no, the last question is Mr. Green gave the cashier 2 $20 bills. Calculate its change. He gave 2 $20 bills. Calculate its change.
$14.60.
How did you get that?
40 minus 24.6. By hand, you would extend it. So I put 40.00, and then you put 24.60, and then you will keep borrowing until you get down to 10, and then you go from there.
Okay, so it's gonna be 14 .60.
I guess.
14.6. This one is wrong because I used the wrong numbers. My answer is wrong from the beginning. So I changed it to the right thing. 1460 is your answer.
Got it.
Alright, so good. So let's move on to the
Where the 40 came from?
because it's two $20 bills.
Oh, okay.
Yeah. Okay, so that's the thing. Okay, so let's move on to some other questions. Yesterday we started working on this paper. We didn't finish. And so we're gonna see how much we can get done today. Where did we left off to? Did we do this? Yeah, we did. I remember doing this. I think we left this. I think we supposed to do this question.
Yeah.
Alright, so the circle theorem again. How would we do this? How would we find M? How would we find M?
Would we subtract 180 from 58?
So close.
And divide it by 2.
And divide it by 2. Why are you dividing it by 2?
I don't know. I just guessing.
Because both sides are equal.
But how do you know both sides are equal?
Okay.
Honestly, I go by the thing. You could I don't know, it look even, so I figured it'd be equal.
It look even? It say not scale, so you can't go and add up. Alright.
Say
it again. Alright. The way we tackle this question is we have to use one of our theorems. And this is what we have. Now if you look at our theorems that we have, let's look at the circle theorem theorems, which you all already know by heart because you all are good students. And you study. So what theorem you think we're gonna use out of these 8 to answer this question?
You probably use the one with the tangent.
Which one with the tangent? A lot of them have tangent. Which one?
Tangent from a point outside a circle are equal in length.
Very good. So this is one that we
Yeah, so it just that's what I mean. You see how they look equal in length? I didn't know that. Okay, it's equal.
This is why it's equal. Not because it looks.
No, but then you see, this just proves my point. It strengthens my point.
Of course, it strengthens your point. It also strengthens mine that we have to use a theorem. Okay, we can't just go on willy-nilly. So we know for sure that these things are equal, right? So this is equal to that because of this theorem, theorem number 7. Okay, so this theorem. This is a tangent. This is also a tangent. And they meet at a point. So when the tangent meets at the point, their lengths are going to be equal. So that means this angle is also equal to M. So in order to find M, we must take we must take 180, minus it by 58, then divide it by 2. And the answer is what? And the answer is what?
661.
61. Very good. Okay.
Are we supposed to remember these? I don't have these on the paper.
No, they don't have circle theorem on.
These people make like to hook up.
Okay. All right. So now we already know what this is. This is 61. Now what is n? What is angle n?
Is that 61 minus 90? I mean 90 minus 61?
Why you say that?
I don't see an invite either.
Because it's touching a point. I mean, it's touching the perimeter. So all the things in this perimeter is 90, right?
Say it
Or
again.
this. Okay, everything that touches the perimeter from the point, from the center, is 90.
Oh, I see your point. But the problem is, right? Remember
Uh-huh.
that. Remember that that only works, right? If it's a semicircle.
Oh.
Yeah. So if we look at the theorem says the angle in a semicircle is 90 degrees. So it only works if it's a semicircle.
So in this case, it'll be from 180 then.
So in this case, we can't use this theorem right now
So
because
I'll have to use 180,
180. What do you mean by 180?
as in 180 minus 61.
Okay, we're
What do you
back.
mean 180
That was so rude. Just cut right off.
No, I'm asking because if we can't use 90, then the best option would be 180.
You sure? Look at your theorems.
We can talk about it, I guess. Like the points that you have, you can mention. Or you want to go straight to that too. We can do that too.
I gotta zoom in first. Hold on.
Right.
Would this be the first one?
This theorem.
No, it wouldn't. No.
When I'll put all that nonsense struggle by yourself. Come on, go ahead.
Ain't even a struggle. I just don't know at this point.
Go ahead.
I wouldn't know the question.
You're trying to find n. Trying to find n. N. You already know what m is. M is 61. You're trying to find n.
For the alternate segment.
Sorry, wouldn't this be the... Wait, sorry, let me look
I got
at
the same thing. Alternate segment can work. Wake up.
Alternate segment. No.
Would it be the one with the tangent line brushing the where the radius with the radius?
Yes, ma'am. Very good.
So so you still minus it from 90?
No, you don't minus it from 90.
Wait, so what do...
Okay, so we got.
What this is saying is that.
Okay, so for.
This is saying that if we have a radius, right, which this is the radius, and we have a tangent, then the angle between a radius and a tangent is 90 degrees. So here, if we know that this is 0, so this is not 0, this is the origin. So that means that if we go from the origin to a point, we know that this must be the radius. So this is a radius, and this is a tangent line. So that means that the angle between the radius and the tangent line must be how much?
90.
Must be 90. So this is 90.
90.
Right? This is 61.
Uh-huh.
And angles at a point add up to
180.
180. So what must n be?
It must be 90 plus 61 minus 180.
Very good.
But Mr. Pate, wouldn't that still be 90 minus 61?
No,
But wouldn't you get the same answer?
I don't know if you would get the same answer, but that's not necessarily true. It'll have to be 180 minus 61 plus 90, which is 129. Which is 29.
No, I was doing the
But I get
shortcut way
29 also.
Say it again.
because if you
Subtracted.
because when I first and I did and I got I do 90 minus 61.
But what's the logic between 90 minus 61?
Well, I didn't know I would be using the tangent line, to be honest with you. I just gone by the thing in my case, say, okay, automatically I would know that this would be 90 because it's touching the circumference. I didn't, to be honest with you, I didn't know the tangent thing. I didn't know that till just now. But I minus it from 90 and I got 29.
That would work
So
too, because you're right. And, because remember, this should be 90 as well. Because this is also a tangent line right there. The tangent line right there. And this is the radius. So n and m should be equal to 90. I just saw that. So n plus m must equal to 90 degrees. True. I don't know if y'all see that. What I mean is, if you look carefully, you see that you have the tangent line here. Let me make that clear. You have the tangent line here. So this is your tangent line. You have the radius here. And so the angle between your radius and your tangent line is 90 degrees. We know that this part is n and this part is m. So n plus m must be equal to what? Must be equal to what?
90. But you wouldn't recommend that way here?
No, I didn't even see that. So it will work.
You think so?
Yeah, of course it'll work. So 90 minus 61 is 29. It's a better way if you ask me. So I was looking at the other side. I was looking at this side. But it comes to find out you can also look at this side too. So 90 minus 61, or you could do 180 minus 61 and 90 give you 29. But it's for 3 points though, so I guess they wanted this way. Anyway, a regular polygon has interior angles of 135 degrees. Hello?
How come I need 90 minus 61 is same answer?
Because like I said, like I was explaining here, this theorem also works for the right hand side. So this is supposed to be 90. Because again, if you look, we have the radius, we have the tangent line, and we have the radius. And so this angle between them should be 90 degrees, according to the theorem right now. It says if we have a radius, if we have a tangent line and a radius, the angle must be between them must be 90 degrees. So here, that's what we have. Tangent line and a radius. So the angle between them must be 90. So n plus.
So you can use either one?
Yeah, you could use either one.
Okay.
Yeah. Sorry for the yawn. Okay, so that's that. So yeah. Now, B says a regular polygon has interior angles of 135 degrees. Calculate the number of sides the polygon has. So we have a regular polygon. We know what is the angle, or what is the measure of each interior angle, each angle inside. So how much sides must this polygon have? Any ideas?
Let me do n minus 2 times 180 over n equals 135.
Yes, ma'am. Yes, ma'am.
And then we calculate it from there.
How you know that?
I learned that from you.
Okay. Very good.
Okay, I'm thinking. What's she saying? Because I ain't in it.
Go ahead, Nancy. Read it for this.
And in brackets you put in n minus 2, and then you close in the bracket, then you're multiplying it by 180, and then you're putting it over 2, and then you'll have it equals to 135.
So with that, once you have that, then solve for n. But how do you remember the formula though? That's trying to figure it out.
Got the biggest penalties, you know, because of not product at a certain time. Is that
You said once you practice it, you remember it, so
but, yeah.
That's true.
it's easy to remember once I practice it.
That's true.
I want to take you don't remember.
Say it again.
Always coming up, but she never remember.
Okay, so what would n be?
One minute, I still working it out. I think I gone wrong somewhere in calculating it.
Yeah.
No, I actually stopped. Okay, when you're dividing by n, would the n automatically be cancelled out?
No.
So it's still going to be remainder n, right?
You have to do something with that n first.
Okay, can I just show you can I just tell you what I have? Can I just tell you what I have?
Yeah, tell me what you have.
Okay, so after you set it up as n minus 2 times 180 over n equals 135, I multiplied 180 by n to get 180 n minus 360 because 180 times negative 2 equals 360 gives you 1 equals to 135. And then I put it over n again. So when I divide it, I get n again. And then I have 180n minus 360 equals 135. Am I supposed to have the n remain like the n still there? Come back?
No.
Right.
No.
So I went wrong there.
Yeah, you went wrong. So the idea is that, and for the benefit of everyone, let's go over it. So the idea is that if we want to, so here, in order to figure out this, we use an important formula. The formula says that the interior angle is going to be equal to n minus 2 times 180 divided by n, where n is the number of sides of the polygon. So again, if we want to figure out what the interior angle is, right, we just have to take the number of sides, minus it by 2, multiply it by 180, and divide it by the number of sides. This is what this formula does. Now, so I in this formula is for interior angles, and N is for number of sides. Now, in the question, they give us the interior angle. What is the interior angle? Based on the question.
135.
135. So we could substitute I. So let's give us 135. Right? And so we have 135. If you substitute, we don't do none to this side. We leave it as such. But we want to get rid of this n in the denominator. So what we're gonna do is we're gonna multiply both sides by n. Okay, we multiply both sides by n. Now that would mean that on this left-hand side, we would have 135 times n. But on this side, we'd have n here and n here, which means we could be able to cancel them two out. Okay, and so once we cancel them two out, then we are left with 135 times n equals to n minus 2 times 180. Now we are able to multiply 180 by n, and then 180 by 2, and that's going to be equal to 135 degrees times n equals to 180 n minus 360. Then we want to send the 180 over because we want all the n's by itself. And so we're going to send that over. So we get 135 n minus 180 n equal to 360 degrees. When we subtract, we get 45, negative 45 degrees. So we have to divide both sides by negative 45. So we divide this side by negative 45, this side by negative 45. So we get that n is equal to 360 divided by 45. So n is equal to 8. So the number of sides of this polygon such that each interior angle is 135 is 8. Now, if it has 8 sides, what do we call that polygon? If it has 8 sides. A polygon with 8 sides, we call it a what? A what?
A regular octagon.
A regular octagon. Any questions at all?
So I basically lost it, and I supposed to bring it over on the other side as well. So that's why I gone wrong.
Say it again.
So I'm supposed to bring it on the other side as well. That's why I went wrong.
You have to multiply both sides by n.
Oh. Right.
Whatever you do to one side, you must do to the other. Any questions on how we got 8? So everybody understand how we got 8? No questions at all. Okay, so let's go. So n is 8. The next question, bearings question. It says that the diagram shows that Peter is standing 60 meters due north of Anne, while Robert is 120 meters on a bearing of 100 meters from Peter. So Peter is standing 60 meters due north of Anne, while Robert is 120 meters on a bearing of 100 degrees rather from Peter. So this is Peter, this is Anne, this is Robert. And so now the question says, show that the distance of Robert from Anne is 124 meters, correct to the nearest meter. This we have to show. So which side do they want us to find, essentially?
The opposite side where the 100 go in, like that direction.
This one, yes. They want
This side, but we don't know that.
Yeah, this one. But the good news is, listen to this, right? The good news is that they tell us what the answer gonna be. You see that?
Yeah.
Yeah. So
Yeah.
all they want us to do is to prove or to show that it's 124 meters. Okay. And so that's what we have to do. Now, here, when we're trying to find missing sides, what could we use to find the missing side?
Like sine rule and stuff like that.
Sine Rule.
Okay, we could use sine rule. What else could we use for sides?
Pythagoras theorem.
Pythagoras theorem.
The
I checked.
the cosine.
The cosine rule, right?
Yeah.
So the question is, which one of them would be right at this point? So let's talk about the Pythagoras theorem. Would that work for this question? Pythagoras.
Guess I can.
I second that.
You second that? Okay. Now,
But that's my main one. That's not my main one, but I know it could work.
okay, now the problem with Pythagoras theorem only works for right angle triangle. Is this a right angle triangle?
No.
I know.
So we can't use Pythagoras. So we throw that away. What else could we use?
Sine rule. That's my
Sine Rule.
Sine rule. Okay, so
That's my
now
first
that's
option.
our first option. Now, the problem with sine rule with this question is that for sine rule, if we're trying to find a side, we need two angles inside the triangle. How much angles we have inside the triangle that we know?
None.
None.
One.
So, well, we do know what this one is.
One. Yeah, 80.
That's 80 because angles are a point. So, yeah, in order for you to find a missing side for sine rule, you need two angles. So you need to know what the angle. We need to know at least two angles. We can't do it without knowing two angles. So sine rule is not gonna work out.
Cosine then.
That's the only thing we have.
I can't believe I said that and I doubt myself. And I said I know.
That's the only thing we have left.
Right.
Yes.
But okay, but you see, this is my problem. How do we know when to apply these stuff? Like, 'cause there's so much rules and
We just system elimination.
yeah, but
Do it
how
again?
do I do that? No, but how to do it in the examination by myself?
Let's follow what I did. The first thing we
I
said.
don't remember all that.
I don't remember. The first thing we said, can we use Pythagoras? Can we use Pythagoras?
No.
Say it again?
No,
Why not?
because it isn't a right angle.
Good. Perfect. So it's not a right angle. We can't throw away Pythagoras. Can we use sine rule?
No,
No. Why can't we use sine rule?
because it doesn't have two angles.
We only have one angle.
We only have one angle.
So yes,
Perfect.
describing that would be
So,
like a plain line.
Remember, for sine rule, if you're trying to find a side, you need two angles. But if you're trying to find an angle, you only need one angle. Okay, so that's the thing for sine rule.
Mr. Badi,
Yes, sir.
when can we use Circle Theorem?
Circle Theorem only works for right angle triangles. Okay,
All right.
that's trigonometry. That only works for right angle. So if it's not a right angle, so then throw away Pythagoras and throw away Circle Theorem. Now sine rule, like I said, sine rule only works if you have two angles and you're trying to find a side. But if you're trying to find an angle, you only need one angle to find to determine the next angle. But if you're trying to find a side, you need two angles. Okay, so we only left with cosine rule, so let's remind ourselves the formula for cosine rule. Cosine rule.
Is that on the paper?
Yeah, cosine rule is on the paper.
Okay.
Thank God. Hallelujah. Amen.
Amen. I received that one. Yes, I remember all them stuff.
Cosine rule. So cosine rule says the following. in any and see, you know, look what they say. Pythagoras theorem. It have to be what? Right angle triangle.
Right.
You see that? SOHCAHTOA. It have to be what? Right angle triangle. But in any triangle, we could use what? The cosine rule.
Sensitivity.
Yes, ma'am.
So how you know the difference between SOHCAHTOA and Pythagoras theorem?
Okay, so SOHCAHTOA, we haven't really done SOHCAHTOA like that in this class, so you wouldn't know it like that. Let me see if I can give you a quick difference. SOHCAHTOA involves sine and cos and tangent. Pythagoras only involves the sides and stuff, like a squared.
I mean, like how you would know when to use it.
Oh, how would you know when to use it? That's a whole lesson. I can't really explain that like one shot. But it depends on what side you're looking for. And the thing about SOHCAHTOA is that SOHCAHTOA is not only for sides, it's also for for angles too. So, Pythagoras only for sides. Okay. So that's one thing. So sine rule says that. So this one is sine rule. This one has cosine rule. So even though they don't say it blatantly in the exam, this is sine rule, the top one. The bottom one right here, the same one. That's cosine rule. This is the one that we want. So cosine rule says that a squared equals b squared plus c squared minus 2bc cos of a. That's what we want to use.
Mr. B.
Yes, sir.
That's the one to the bottom of cosine rule formula though.
This is cosine rule, but this is for angle. We're trying to find an angle, miss an angle.
All right.
This is cosine rule for sides. Okay. Good. So we're gonna use this formula. Okay.
Mr. Petit, on the Jingle lessons, could we remember we asked for topics? Can we incorporate these, but like learning how to know when to use them? Because I think that's a big issue.
Okay, no problem. Sure. Write it down so you can remind me again. Like, and try to keep it in memory as well. How to use them. Okay, so this is one. So now let's go to. So we see that bearings applies cosine rule in it. See that, right? So that's one thing about bearings. Bearings is one of those topics where you have to know. Okay, so let's use the cosine rule. So we said let P, this is the answer for A. Let P equals the distance in meters of Robert from R. Then to find P, we use what? The cosine rule as follows. Remember, for cosine rule, we're gonna let
So today we excuse for a second.
we let 120 be B, and we're gonna let C be 60. So it's gonna be, let's see, let me see if we applying it right. Sorry. Yeah, we can let 120 be B and C be 60. So it's gonna be B squared, which is 120 squared, plus C squared, which is 60 squared, minus 2 times what? BC. Right, that's what this equation says, right? 2 times BC. So that's what? That's 2 times 120 times what? 60. And then cos of the angle A. Remember?
Max.
Hold on, but isn't the cos supposed to be like that on the equal sign?
Because everything
Say it again?
you can't.
Isn't the
you can't
cos
object in
A
this.
supposed to be
You
like
can't not take this car.
from on
So
at
you
the
know,
equal sign?
And you can't leave the airport without getting your car. So because it would sense how you get good, you know.
So look at the formula. Cos of A.
Oh, okay, I see.
Okay, so this would be used. Okay, so now we're gonna simplify it. 120 squared plus 60 squared is what? I get 18,000. And then 2 times 120 times 60, I get 14,400. Okay. Now, after we do that, we're gonna subtract 18,000 with 14,400 times cos of 80 to give us 15,499.466242. Of course, we want to take the square root of both sides now to get rid of that square. So once we take the square root of both sides, we're left with p on this side. And the square root of 15,499 is going to be what? 124.496. And if we round it correct to the nearest meter, we get 124, which is exactly what they said that they wanted us to show, that it's 124. Okay. Any questions on this? Not really quiet tonight. And nobody asking no questions, so I guess everybody understands.
I'm trying to understand it. So because you gotta understand it before you have questions.
So take a good look at it. Let me know if you have any questions.
To incorporate the cos 80 within the 14 thing in front of it.
Say it again.
Did you multiply the second part of the equation? Let's say 144.
You mean these two?
Yeah.
Yeah, I multiplied them together.
Oh, okay.
Give me one moment, please.
So I'm trying to.
All right, go ahead.
No, sorry. I was trying to put that part in my calculator to see if I could get the same result you get.
So
Okay.
let's do it. Let's put in the calculator to see.
I'm trying to understand how you multiply cos by a number. My first time doing it, so I want to see.
No, just put it regular in the calculator. So
Yeah, I really noticed I got the same thing. I just wanted to see if I would have get it on my.
thing still?
No, I got the answer. I just wanted to make sure I could do it on my own.
Oh, okay. So 14,000. So that is 400. Cos of what? 80. Why is the sign?
Yeah.
Cos of 80 is. We did wrong now. Oh, degrees. Good. So once you see them two close together like that, that's multiplication. Okay. And you don't even have to tell the calculator that. Just put it there. Okay. And it'll automatically multiply it. Alright, so that's how we get that. Alright, any questions before we move on?
No, sir.
Okay, good. All right, one moment. Okay, so let's move on to the next question. B. Calculate the bearing of Anne from Robert. Calculate the bearing of Anne from Robert.
You said the bearing from Anne.
Of Anne from Robert.
Anne from Robert.
Yes.
So basically, they really asking us to do from Robert to Anne.
Yes, basically.
I hate that foolishness.
All you gotta do is once it say from, so say from, wherever it say from, that means that's where you can start from.
Yeah.
That's all right.
It's basically Robert to Anne. Okay, so how do we do that actually?
Yeah. How do we find the bearing?
That's 5 points. It sounds technical.
5 points. Yeah, that's exactly 5 points. Any guesses? Remember for bearings, and before I even give you all that's just what you think.
Okay, bearing is in degrees, right?
Mm-hmm.
I don't like it. Because that means we'll have to find our knot again.
Yes.
And then then we don't even have any numbers on that side. That's even worse.
That's where difficulty there, right?
Yeah, no, I'm not going to rock this brain of mine tonight.
Anyone else wanna help, Nancy? Come on, I gotta hear from y'all, especially my Bgcse crew. That's Ricardo, 1. Who else there from? Nancy. Alicia. How do we do this? Hello? Oh wow, this is terrible.
Mr. Petit, no one answering because I had, you know.
At least say, okay, I don't understand or I don't know.
That's what I would say answer, but I know it wrong.
Just, okay, at least let me hear you.
I don't understand it.
I just want to know the scale. I just want to know the formula.
I would say measure it, but I know that wrong.
It's not the scale, so.
That's how you saying, yeah.
Problem.
Yeah. Okay, this might sound so crazy. Okay, you see where we have the. Can we even like pick? Okay, you see the angle. Can we even go based off like the triangle here? So let's say if we find like the degrees inside of those, and then try to form a circle out of it. Can we do that?
Okay, help me understand what you mean.
Okay, for an example, but like you see how we have 100 here, right?
Yeah.
So we know the opposite side is 80. But then if we do a circle, we know that where Peter is going to be 180 because that'll be a circle. So I was wondering, can we do that for all to try gauge the numbers? That's just a suggestion. I don't know.
Good suggestion.
Is it possible?
Well, the first thing we have to do, we have to identify the bearing first. Right? That's the first thing. Before we even know what it is, we have to figure out what it is. Like, we have to identify it. So, in order to identify the bearing, the first thing we have to do, we have to draw north from Robert. That's the first thing. And so, let's do that. So, the first thing we do is we draw north from Robert. So, this is where Robert is. So, we draw north from Robert. Now, the bearing that they want us to find is going to be this reflex angle that starts from north and extends all the way to this line. That is the bearing that they want us to figure out. That's the first thing you need to know. So the green angle, the green reflex angle, is the bearing that they want us to determine. Okay. Now what I did was, they already gave us this north. I drew another north, and if you look carefully, if this is 80, this must also be 80. Why?
For
Opposite.
waterfall
Alternates.
was, I guess you know what to spend.
Alternate angles are
Equal.
equal. Very good.
Equal.
Yeah.
So I was close when I said let's do a circle.
Yeah. Very close. So
But how? See, this is my point. How did this didn't automatically connect? Like this is 80, so that would be 80. That didn't.
This is 80. Very good. Now,
But how do you know when to apply these kind of stuff to the equation? That's my problem.
how do you know? You know because if you draw, because look, this is a straight line. If you draw another line that's parallel to it, this would be a transversal. And so you could easily apply the alternate angle theorem. You know what I'm saying? Because you have two parallel
don't
lines.
see what you're saying.
How you say
You have two parallel
easy.
lines, and then you have a transversal.
That's the same
So
thing.
this angle and this angle will have to be equal. All right. Now we want the green angle though. So think about it. If we want the green angle, we know that let's call the green angle M. That's our bearing from. We always start north and go clockwise. All right. So this is Robert. We start north and go clockwise always until we end up here. So the angle, this reflex angle in M, this reflex angle, we call it M. The way that we're gonna get it is if we notice that angle M plus angle A plus 80 must add up to what?
360 because it's a circle.
360.
Good, because angles in the circle, angles at a point add up to 360. So if I know what A is, right, all I need to do is add A and 80, then subtract it from 360, then I could get M. See what I'm saying?
So we have to find A.
Exactly. We need to find A. So
A, right? Hold on. That's A. Would A and the outside of A be the same thing?
A and outside of A, so you mean this?
So no. A and then next to it.
Next to it, this way?
No, opposite.
This way?
Yeah. Because if you split it in half, you basically split in the circle in half. So wouldn't M side be 180?
It's 180, yes.
And then so we automatically know that this 80.
This is 80, so this is 80?
No. So it means when you split, wouldn't you be like 2A and then you get 50-50?
No. We don't know if these are exactly equal. We don't know that.
Oh, that's what I was
Yeah,
asking.
we don't know if they're exactly equal. We can't say. So we need to figure what A is. And A,
Okay.
the thing is
Would
that
A be,
the good thing is that A is inside the triangle. So we could use properties of the triangle to help us find A. See what I'm saying? So the solution reads as follows. Let M equal the bearing of Anne from Robert. Then it follows that M equals to 360 minus A plus 80. Do you understand now what I'm saying here? Right?
I think so.
All I'm saying is this is the bearing, M. And in order to find M, we must subtract 360 by A plus 80. Now, in order to do that, we have to use the sine rule to find A. So not the sine, the cosine rule. Can we use the sine rule though to find A?
I don't know how it's like.
Can we use what rule?
Can we use the sine rule instead of the cosine?
Yeah, and we have two angles.
Where the two angles is?
Hold on.
Oh, Jesus. No, we got one. No.
How did you use the sine rule if we ain't get no right angle?
Remember, sine rule doesn't have to be right angle.
I thought it's
I don't.
Pythagoras theorem would have to be right.
Pythagoras theorem have to be right.
Don't we need two sides for this one?
For what?
I think we need two angles.
Yeah, two angled sides or
Remember
something
we
like that.
said. Remember I said if you're trying to find a side, you need two angles. If you're trying to find an angle, you only need one angle. So for this triangle, we have three sides. We know the three sides, and we have one angle. So of course we could use sine rule to find A. Okay. We could use sine rule. I just didn't want to use it. We could use sine rule. I just using cosine rule. I just find that cosine rule for this question feels better. But we could have used sine rule too. Okay? Because we have three sides and we have one angle. We're just trying to find a missing angle. So we could use sine rule. We couldn't use sine rule from the beginning because we had an angle here, but we was trying to find a side. So if we're trying to find a side using sine rule, we are going to need two angles, right? But since we're just trying to find an angle here, we could use sine rule because we only need one angle. Okay, I hope you all follow. Anyway, cosine rule. So we're gonna use cosine rule to find A. Remember cosine rule here. It's in your booklet. Cosine rule is cosine rule. Just add that. Let's cosine.
Mr. Petit, I didn't see. I have to, when I go to the exam, I have to be writing all of these things on my hand to take into the examination because this is too much.
No, you're not gonna do that.
Watch them kick Nancy Ray back on that road.
For nothing. Don't write on your hand, man.
I just messing, but this Petit, it's too much. So honestly, I
say you forget to lose it this morning.
Okay, so this is cosine rule. This cosine rule says cos of A. Notice that we're using the one for the angle this time. So cos of A is going to be equal to B squared plus C squared minus A squared. We know that B is going to be, we call B 124 in this case. So 124 squared. C is going to be 120. So that's this side. And A is going to be, of course, these are going to be corresponding. So if this is A, this must be small a. So that's going to be 60 meters. So 124 squared plus 120 squared minus 60 squared. So once we do all that, we get 21676. So let me do it in a calculator to show y'all. That would be, what did we do? That was, let me use math paper. That was, what it was, 124 squared plus what? 120?
120 squared minus 60 squared, I think.
60 squared, yes, ma'am. Equals 2176. I don't need this advertisement.
My question is, what bearings got to do with these formulas?
Bearings have to do with everything geometry. So for bearings, everything you learn in geometry, you apply. Everything. So alternate angles, corresponding angles, vertically opposite, angles on a straight line equals 180, angles at a point equals 360. Bearings, all them is just like, bearings almost like circle theorem. We use all them rules.
So, Mr. Badiq.
Yes, sir.
Anytime we doing bearings, we have to use the formulas.
We have to use whatever formula apply to help you to get the angle. So, like I said,
so formulas a must.
Yeah, formulas is a must. Is a general rule. It depends. They might give you an easy bearings question where
what you call easy?
What I call easy, I can show you what I call easy. What I call easy would be, say, something like. Okay, it wasn't this paper I saw it. No, this is paper 3 stuff. I saw an easy variance question in one of these papers. I wonder if it was this paper. It was just basically about lighthouse. And
You mean the lighthouse A and B and all that?
I trying to figure where I saw that.
We don't do that.
Yeah, but that was bearing. But
You're just calculating basically.
no, not
Yeah, that one a little more simple compared to.
that one was. I can't remember which paper it was. Can't remember which paper it was, but there was a lighthouse question on bearings, and that one was simple. It didn't involve much of these nasty formulas. Okay, so anyway, 2 times 124 times 120. That's give us what? 2976. Dividing those two. Okay, you gotta be careful now. So for this one, after you're ready, find it here. We have to do the cos inverse of both sides. The reason why you want to do the cos inverse of both sides is because we're trying to isolate A. So cos inverse times cos inverse of cos of A. These two are going to cancel with each other because this is inverse. So we have something and it's inverse, so it's going to cancel with each other. So leaving us with A. Okay, so and then cos inverse of this side is the same, stays the same. So what we did here, we did the cos inverse of both sides. So let me make that very clear. We took the cos inverse of both sides. Okay, cos inverse of this and cos inverse of that. So A is going to be equal to cos inverse of this, which is going to give us 28 degrees, but that's correct to the nearest degree. Okay, so we know now that A is 28. So since A is 28 degrees, we know that M, our bearing, is going to be equal to 360 minus A plus 80. A is 28, so it's going to be 360 minus 28 plus 80. So M is going to be equal to 360 minus 108. So M is 252. All right, so that's it for bearing. Any questions on this?
Mr. Batty, do some calculators just naturally know when to go into radius and then degree?
No, you have to set your calculator to degree mode.
Well, I didn't do anything, but it still gave me 28, so I wonder if I...
That means that your calculator is already set in degree mode, so don't change it.
So when I want to go to radius, I have to change it?
You never would have to go to radians for this level.
Like the fight would be
Okay.
the time and line down.
So just don't change it. Make sure. Don't change it.
What button changes it?
And you go alt mode. So you would you would always, but not mode by itself. You have to press mode along with
Don't tell me, I don't know.
Yeah.
But you would always know if it's in degree. You could always check. So if you want to check if you're calculating the degree or radians, you could do an easy check. So always do sine of. So if you want to check if you're calculating degrees or radians, do sine of 90. If you do sine of 90, you're supposed to get what? If it's in radian, if it's in degrees.
1.
You're supposed to get 1, always. But if you do sine of 90 and you end up getting 0.89 whatever, we know, okay, this thing is not in
Yeah, you gotta go through
degree mode and radians.
Okay.
Okay, good. So that's that for mathematics for today. I thought we was gonna cover some more of this paper, so we had some excited things to do. But we can't finish it. So do this for homework. Do 14A for homework. AI, AII, and AIII. Do that for homework for me.
Can I screenshot it?
Certainly. Okay, any questions based on what we just did out with the cosine?
Got already.
Is M a part of the answer?
M is the answer. M is the variable.
What?
Yeah.
It's only for Bgcse people, right?
Yeah, that's what we said. We said, remember, M is this reflexive.
So what were all this coast was for?
Coast was to find A. We needed the A.
It'll blow me down. Could you go
Nancy, get lost.
Are you aware what's going on, Miss People?
Oh well, Miss Petite, I gone for 5 minutes. Come back to all of this. I been lost
Exactly. So why you coming and not being lost? You lost.
because she was here all this time.
listen to me.
Asking.
Listen to me. You can convince me that 28 was an M. Listen to me.
Wow.
So I think I
don't
someone
know how
said
much clear I could be. I said that M is.
Listen to you. I don't know.
That's what I said.
I
said, now we use cosine rule to find A.
I let my imagination follow, and this is what happened.
Oh my goodness. And then we find A, and then we use it to find M. I want F from 1.
Yeah.
How you feel about this question? Is 1 F?
What's up, DD? Give up it.
Everyone crying for help. Even I was crying for help. Everyone was fatigued. Everyone crying for help.
1, where are you? No? Ricardo, what you feel about this question?
I mean, you use some more practice on it.
More practicing. You know, when we was in Bgcse questions, everybody was like, oh, 25.4. Yeah, 12 times 75. we slide over the Bgcse questions for 2 seconds. And we fall up. But don't worry. We're going to get it. Alright, so let's go. So we're going to do some English today. Alright, after this.
I'm going to step out just for 2 minutes.
Yes, please. Just a little.
So let's transition over to English. Hopefully an interesting topic, in my opinion. Okay, so we already talked about in English we talked about how you should structure essay and the different things that they are looking for. Is the essay mature? Is the material or content making sense? The next thing is style. It's the style varied. The next thing is accuracy and structure. Today, we're gonna be looking at. I want us to look at ethos, logos, and pathos, and then after that,
What?
yeah, ethos, logos, and pathos, and then after that, that's gonna help us because then we're gonna go to recognizing. No, then we're gonna look at Tolman's model for analyzing arguments, and then we're gonna look at recognizing a writer's tone. Okay, so those 3 things are it's gonna be on the lineup. I don't know how much of it we can get done today, but those are the 3 main things that I want us to look at. We're gonna look at number 1, ethos, pathos, and logos. Then we're gonna move on to Tolman's models for analyzing arguments, and then we're gonna go on to recognizing a writer's tone. So we can see how much of that we can get covered today. If we can't cover it all today, we're gonna leave the rest for Wednesday. Okay. But give me one moment. I have to do something and come right back. Give me like 5 minutes. Cinco. All right. So let's continue on. Okay. So
You were so concerned.
yeah, right. Yeah, right.
You was worried.
Kennedy, I didn't hear you all through maths class, man. What's up?
I was confused, and if I would have if I would have talked, I would have been whimpering.
Oh my goodness. Oh wow. Monday. Today is what, the 9th of May, right? 20,
Yes, so
2020. I almost write 2020. All right. Okay, so English language. Like I said, today we're gonna look at ethos, logos, and pathos. All right. Now these are what we call. Anyone ever heard the terms ethos, logos, and pathos?
Yes, so they're like the states of persuasion,
They're the what?
like the states of persuading, how to persuade somebody.
Ah, wow. Got it. Got it, Kennedy. I mean, she was I just turned the mic over to you. Finish the piece of glass, huh? Very good, Kennedy.
She would love to.
Of course.
No one to listen to me. No.
That's not true. All right. Okay, so ancient what we call these rhetorical strategies. Huh? So these are ancient rhetorical strategies. So the ethos, pathos, and sorry, logos, sorry, and pathos. Now the study of rhetoric is an old one. It's actually one of the first academic disciplines. So they've been studying language and critical reading and persuasion, like what's her name? Kennedy said, for a very long time. It's one of the first academic disciplines. In his treatise, that's what it's wrong. Yeah, in his treatise. So I just given you a little backdrop on where we get the words ethos, logos, and pathos from. In his treatise on rhetoric, so someone writes when we say a treatise, what do we mean? What do we mean when we say a treatise? If I say Kennedy did a treatise on a certain topic, like someone did a treatise on gravity, or someone did a treatise on
Like an essay?
It's an essay, but it's a deep essay, a thorough essay.
So like a short read poem?
Not a short, right? A treatise. When we say we're doing a treatise on a
A
topic,
detailed
yeah, a detailed analysis on something, right?
yeah.
So
Or something proven to be true.
yeah, trying to prove something to be true. So if we do a treatise on gravity, you know that like 500 pages could be, you know what I mean? Not just you just going deep. This is your findings. You trying to listen. Hey, I know what I'm talking about. So in his treatise on rhetoric, the Greek philosopher anyone would a guess who I want to talk about? The Greek philosopher.
Aristotle?
Yeah, Aristotle. Everyone.
Oh, it's right.
Yes, you're right. Aristotle states that the three main ways. Sorry, states that the three main ways to persuade an audience are by what? Appealing to the ethos, logos, and pathos. Now, can someone guess why is this important for us in language? Why is this information important for us in language?
To persuade the person to persuade the person properly so that they would not lose interest for the
Wow, Kennedy, you on a roll. Just like Miss Cooper today in maths. Yeah, you're right. When we are writing our essays, we are going to be we're going to be persuading people, right? We got to persuade them that, hey, our point of view is the best point of view, right? Our point of view is the one that makes sense, right? And we want to know how to do it well, because based on how well you are able to do it, that determines how well your essay is and how better grade you get. And it's not only for language; it's also for people who take in RK, and for people who take in social studies or history. You have to be able to sell your idea, and that's basically what the essay is about, right? Selling your idea to your reader, okay? And so by learning how to do it using ethos, logos, and pathos, we could be able to write a better essay. Okay? So ethos, so let's start with ethos. Right? Ethos, from which the English word.
Oh, are we writing the first paragraph?
Yeah, definitely.
Okay.
I need that information.
Yeah, the methodology
Oh
set.
my goodness, that's write
See,
it for
I
the
don't,
sake of completeness, please.
in language, I'm not supposed to write, you know.
Yeah, yeah.
Write it for the sake of completeness, please.
All right. Perfect.
Okay.
Thank you so much for being a cooperative student. Ethos, from which the English word ethics is derived, refers to the writer's need to what? Anyone? What would we say ethos? What we mean? Like, what we doing?
Like fox?
Fox? Okay, that's close.
Stating.
So, in order to be persuasive, right? In order to be persuasive, you must, even before you state facts, right? And, stuff like that. You must what? Let's say, for example, and I'm only using this as an example, okay? This is not to degrade anyone, okay? But let's say, for example, someone come to you, right, and they have, tear up clothes, they smell bad, their teeth are not brushed, they have, peasy hair, and, they look like they ain't bathed for days, and and they come to you trying to sell you some perfume, right? And it's Cooper, please.
That was me. That was
Oh, that was Kennedy.
That was Kennedy. I wouldn't laugh at such a.
Yeah. I know you. So they come to you trying to sell you some perfume. Would you be likely to accept that perfume?
I can tell them they need to use it.
No, I'll be honest. I'll pay for it, but I wouldn't take it.
You would pay for it, but you wouldn't take it. Okay.
That's a waste of money then.
But
I'll just tell them they need to use that.
they need to use it. I'm okay. We're not talking. I mean, like,
No, because if they come to that, obviously in your mind you're gonna know that they need money.
okay.
Because no one would sell you something looking the way they look if they don't have a need.
Yeah, I understand. But okay, they come to you trying to sell you this perfume. They saying, "Hey, this perfume is the best perfume in the world," and I found this to be the, this has to be the best one, right? Now, how credible is that person to you?
What do you mean?
Look great.
Yeah, yeah, they ain't really credible, right? I mean, they might be stating facts, like, that, hey, this probably is the best cologne in the world, right? But the mere fact that their presentation is what? Poor.
Yeah, it defines the product.
It really make it seems as if, you know, what they're saying is not true. So another
It's not
thing is,
representing.
yeah, another thing, for example, if someone is excessively obese and they come to you trying to say, hey, you know, you should really try the keto diet. It really works for me. See, and you're like, wait, if this thing works for you, why you are still 300 tons, right? So,
False advertising.
so yeah, so the problem is, even though it might really be the best, program in the world, they don't do the very first thing that every writer need to do. And when you try and persuade someone, the first thing you need to do, even before we get into the statement of facts and the other things, the first thing that the writer need to feel from you is that they need to feel that you have some credibility. Okay? So ethos refers to the writer's need to establish credibility. So how are you going to, credibility. So how are you going to show the reader that you are credible? Because if you don't show them you are credible, you could be stating the most facts and you could be right. But if you don't stand as someone who is credible, even the person who might be saying something wrong, because they appear to be credible, they would be more persuasive. Do you understand that?
Yes, sir.
So to refer back, you're trying to say you must go with a solid foundation.
Yes, you must have a very solid foundation. So,
Okay.
so the first task in persuading an audience is to hold the audience's attention. Therefore, right, the writer's work therefore, not the writers, but therefore, writers work hard to establish credibility early by presenting themselves as worthy of the audience's trust. That's how you have to present yourself as a writer. That, hey, you can trust my judgment. So when the reader read your stuff, they should feel that, hey, this writer know what they talking about. They ain't just guessing this. They ain't just...
Okay, can you give me an example?
Yeah, we come into plenty examples, right? So ethos is
Write an example.
Say it again.
Write an example.
I wouldn't say writing examples, but general principles.
Okay, that's better. That sounds good.
Okay, so yeah, so you need to establish your credibility, because if you don't sound credible, then the reader is gonna look at you like, even though you may be saying the best thing and your point may be the most rightest and valid and the most valid point in the world. Yes, ma'am.
So these points are when you're writing a persuasive essay.
Not only when you're writing a persuasive essay, it's also when you are writing, say, an expository essay, when you have to say I disagree or I agree. So that's also for these types of essay. All right, so the readers have to trust you. Okay, so there are a number of methods, and this is also, and I should mention, this is also for people who are doing reading comprehension. When they ask you, how does the writer work to you know, convince the reader, or how does the writer work to you know, to strengthen their thesis, or how does the writer work to drive the points home to the reader? You think about what the writer do. You think about how the writers try to establish credibility. You think about the writer's logos, and you think about the writer's pathos, right? So when they ask you a question like that, what methods they use, whatever, that's where ethos comes in, logos comes in, and pathos comes in, along with the rhetorical devices, the literary devices that you already know. So this is twofold. This is for when you are writing, and this is when you are looking at the work of someone else. Okay, so how do they try to establish their credibility? You know what I mean? And convince the reader that they are the ones who are worthy of the trust. Now, this can be seen in listening comprehension that we did before. Remember, we had the man named, we had Charmaine. What's the man name was? Mr. We had it. Yeah, Mr. What's the name? What the man name was? I don't remember the thing about the horses. Sorry, donkeys. What's the man name? His name was what?
Henry?
Henry.
Henry? Henry.
Yes, sir.
So look at this question. This is a question on Ethos. It says, what is one possible reason why Jessica chooses to call Henry for help? Right? You see why this is a question of ethos?
You can explain.
Because why would she call him for help?
Just he's knowledgeable.
Because he's knowledgeable about Inagua and wild donkeys, and because he works at the Bahamas National Trust.
They have a good relationship.
Yeah, the good relationship is good, but in terms of ethos, the dialogue between them has credibility, right? Because the person who's talking works at National Trust, and he is very knowledgeable about Inagua and the wild donkeys. How do we know that? Because the man lists so much details concerning them. So that was the examiner's way of establishing in your mind, as, because I mean, think about it. Did you ever once during listening to their dialogue
Audio.
or their audio, did you ever once ask yourself, I wonder if what this man's saying is true? Did that ever enter into your mind? To say, boy, that.
No.
No. Like, you just, even though you don't know much about the wild donkey, you just automatically accept what he says is true. Why? Because at the beginning, they already established ethos. They already established the credibility of the person who's given the information. You see what I'm saying? And so that made us persuaded that what he was saying about the wild donkeys in Inagua was true.
They're actually true?
They are actually true, right? But
I wouldn't. I just don't answer the questions.
So
I
you're
think it is true.
say it again, yes. So that's a use of ethos there, right? And so we could have put that in the methods too, using ethos, establishing credibility. Okay. All right.
So what you're saying is that we believed him because he stated his foundation.
Yes, he stated his foundation.
Okay. Relating to the statement.
Yeah, relating to the topic at hand. Okay.
Yeah.
So, good. So there are a number of ways for establishing ethos with an audience. They include So how can you establish audience ethos, and how can you notice when an audience and how can you notice when um, a writer is establishing ethos? Okay. The first one is, there are many ways, but the first one is citing respected sources. So by citing an established credible source, a writer can associate herself or himself with the ethos of the text or the writer. So you wanna so if you're reading something and they cite sources, the source of the dialogue information was from Henry, who was a credible source. Sources that would be credible would be like encyclopedias, statistics from, stuff like World Health Organization, statistics from, you know, um, big entities like um, or statistics from like journals, medical journals, or academic journals or any of those things. When you see an author does that, they are trying to establish ethos. Okay. For example, I don't know if you remember. If I can pull it up. This is a long time. Where are we? Gmail. See if I can pull it up to see if I could pull it up. Give me one moment. Stop presenting. Let me show you something. Mm, okay, I think I got it. Okay, good. Good, perfect. I have it up. All right. So, for example, if you remember the essay that I showed you that I wrote, and the way how I established ethos is, if you look carefully, right? I started immediately. Look, I said, this is it. Okay, good. I said, this is establishing ethos regarding tourism aid to temporal prosperity of, in the past, Claire 2000 wrote. So here, what I did, I cite sources and I give the page number and everything. So here, what I was trying to do, I was trying to,
Yes, sir.
I'm no expert in no tourism, so I quote from people who should know. And then, of course, if you look, what is saying, the full thing is just a part of it. You would see the references that I have for each of them, right? So when you cite sources, or when an author cites sources or cites statistics, like here I have that the majority or 93% of stopover visitors to the Bahamas said that they were likely to recommend the destination to their friends. Citing statistics, citing credible sources, realistic statistics. They are my way, or writer's way, of establishing ethos. What I say, as a matter of fact, according to by establishing ethos, right? Credibility. So I am not making things up. I am just quoting from respected sources. Okay, so that's a way of establishing ethos. Another way is, this is very good, appearing organized. Remember the example I gave you about the gentleman who came to sell you some galloon, but his his shirt was dirty, holes in it, he didn't smell good, whatever. He didn't appear organized, right? And so you wouldn't take him if he can't fix himself. How could he try to fix you? You know what I mean? And so appearing organized is very important. So yeah, that's why I stress to y'all to write in print. And I stress to y'all, try to write as best as you can. The reason why you want to write as best as you can is because when your work look a certain way, that would establish some ethos, right? It would make you seem as if like you know what you're doing, right? And that would establish inside the reader some trust, right? And so when the examiner start to read your work, even me when I'm marking my students' work, the ones that are better, well written, I am more convinced that they are going to get the right answer, and most of the times that's what happens, right? And so writing clearly and neatly is a good way to establish ethos. So appearing organized, right? Some readers, particularly academic ones, appreciate a well-structured argument with a clearly well-structured, with a clearly stated thesis. So what does that mean? You don't want to be this way and the next way. You don't want to, and that's why even when I was explaining how to write an essay, I would tell you all, okay, in the introduction, state your thesis, give your 3 points. In the same order that you give your thesis points is the same order you must explain them in the paragraph, in the different paragraphs. Why? You're trying to establish ethos. You are pairing organized, right? You don't want to, and that's why you don't want to, that's why you want to avoid.
You organize? Oh.
Yeah, that's why you want to avoid, the grammatical errors. You want to avoid the spelling errors. You want to avoid, we call it digression. Like you want to avoid, running on a tantrum, right? That's why you want to stay focused. Whatever your point is, you explain that point, and you stay to that same point instead of the same point, say the same point, say the same point. That's you telling the reader, hey, I am focused. I am organized. I know what I'm saying, and I know what I'm doing. You know what I'm saying? So that's going to help you when you are writing, and that's going to help you when you are in an exam. Because what the examiner is going to say is, this is a focused reader. It's an organized reader. This reader, not reader, this is an organized writer. This is a focused writer. They are organized. I could trust what they're saying, right? I will be more persuaded at their argument because it looks like they making sense. You know what I mean? So that's one of the criterias of establishing pathos. The next one is number 3. In order to establish ethos, you want to letting the language fit the context. Can anyone explain that to me, please? Letting the language fit the context.
You mean as in using the right words to describe what you're saying?
Yeah,
Right.
using the right word to describe what you're saying, and also avoiding what?
Childish words or
Avoiding
words
childish
that
words. Yeah, words that you don't.
Um, avoid simple words that would just blatantly put it out there, give your audience a chance to think, I guess, or something like that.
Our job
Yeah,
was
but I'm also I was trying to aim at avoiding slang, right? Avoid slang. You can't say yeah, true boy, you know, hard go, you know what I mean? Yeah, you see. No, you wanna let the language fit the context.
Yes.
You talking about teenage pregnancy, or you talking about adolescents who are malfunctioning, or you talking about violence or crime, you're talking about why school dances should be permitted, whatever you're talking about, let the language fit the context. And as a general rule, you want to be formal. All right. If you include dialect, they should be in quotations. All right. To let the reader know that this is not a general part of your thing. You just did it to make a point. So let the language fit the context. By doing that, the reader could say, "Hey, this is this person I could trust." Why I could trust them? Because they know what they're doing. They're not using inappropriate language for the context that is given. All right, and all these help to, whether you believe it, whether you recognize it or not, all these help to make your writing more persuasive and help you get a better grade. All right, all these things. And the more of these things you don't have, the more the reader is going to be like, okay, yeah, I don't really believe you, and yeah, you ain't making sense for real, you know? And so you need to be careful. So like I said, you have the best argument. You could have the right argument, but still, based on how you present it, the people are not going to believe you, and your writing is going to be poor because you didn't establish credibility. And you do that by citing respected sources, appearing organized, and letting the language fit the context. So applying the correct discourse can easily grant one credibility. On the other hand, the wrong discursive conventions can quickly destroy one's credibility. So it reminds me of one time when um there was someone who was a major public figure, and then they went ahead and they stick them with a finger, right? Um that is not a good way to establish credibility.
What about Wilson?
Oh yeah, Will Smith with the punch, right? Um I mean, again,
Slap.
with the slap, sorry. Um it's the same thing when you're writing. So when we say discursive conventions, what do you mean is that um basically rambling, right? Or you know, you move from one thing to the next, one thing to the next. You're not focusing what you're saying, right? So you're wandering roundabout, you know what I mean? Long-winded, too wordy, right? Um, uh, so you don't know exactly what you're talking about. So yeah. So number 4, another way to establish convent another way to establish credibility is to be genuine, right? So by meaning well, okay. Now, often when a writer, presents herself or himself as well-meaning and ethical, readers will grant the writer's attention. And I mean, who wouldn't, right? If someone is you know, not reasonable, right? If in their writing and they're not meaning well and they're not genuine, and you can see selfish ambition in their writing, you ain't gonna pay them much attention. It's like say for example you write an essay, right? And the essay is why students should be permitted to have afternoon dance or to have dance, have dance in the afternoon after school, right? And you go ahead and you say, yeah, they should be allowed to have afternoon dances because that is fun. And who likes school anyway? School is just a waste of time and it's boring. So cheapest they have afternoon dances to have something that is fun because you only live once, right? That's your point. And you put that on your essay. Now, that might be what you actually believe, right? But don't put that on that essay, right? Because when the examiner read
If I
that,
actually put that, we're gonna
like when the examiner read that, or when a reader read that, they're gonna be like, this child, do they mean well? Like you telling me that okay, school ain't make no sense. The only thing that makes sense is fun, fun, fun. I mean, that might be how you feel, but that is not gonna establish your credibility. Like you could sound like a immature, I hate to use the word idiot, but that's how you could sound, right? You want to sound mature and well-meaning. So even if you on the side of for dance, you could say something like, school is an institution of learning, and learning is important for, you know, ensuring that the members of society are literate and that they are purpose-driven, right? However, there needs to be a time where students are able to socialize and to have a balance between working and playing. And so therefore I agree that, you know, that dances should be allowed. Now that's way more balanced. That's like you show the reader that hey, you actually mean well. Like, you know, you ain't just about play, 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 and play, 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 and fun, fun, fun. Okay, so yeah, that's better than mine. You wanna mean well. That establishes your credibility. Okay. Do you understand that?
Sure.
Sure.
No, I say yes, sir.
We get that. Okay, good.
I got you.
Okay. The next thing
I
is
got it.
this one is tricky. Right? This one is tricky, but it can also work depending on what essay you're writing. And that's why I kind of leave it for last. Relating to the audience on a personal level, right? You gotta be careful how you do this. For some audiences, credibility is gained by becoming insider. So a personal connection is best. All right, so sometimes it could be good to give a personal example, okay? And the reason why is because you state in why you believe something is true. So obviously your experience in life is going to form why you believe something is true. And so, and sometimes readers want to hear what you've been through, uh, and how that forms your overall point. And so, say for example, you know, you're trying to make a case that um, there should be a curfew. Okay, there should be a curfew um, for everyone at 9 p.m. Right? That's what you want. That's the case you're trying to make. And let's say, God forbid, that um, you had an experience where you was molested um, in the night at around 11, and so you having that experience, you know what that meant and how that felt. So you saying, I think that the cutoff point should be 9 because, in my experience, the reason why it happened is because it was late at night and people was allowed to roam around, and then I got caught in the wayfire. Now that's very personal, and that is going to establish your credibility, and the reader's going to be like, oh, I see why you feel that way. They could feel your point more because it happened to you. You know what I mean? And so, you know, especially in JPR, personal example is good. In English writing, you have to be careful with personal example because personal examples could doesn't always show um the general scheme. So say for example, you say that you got hurt during the night, right? But that's only you, right? I mean, um, and that probably only happened to you once. And a lot of times you went out after 9 o'clock in the night and nothing happened to you. So that one example is not gonna be enough to make the strong argument. So along with personal example, you can try to be more general. That's where statistics come in and saying, instead of saying I was um, molested, you can say, well, majority or a lot or a great number of, males or females are molested during the night. Because of, there not being a curfew and um and you can say, okay, I am one of them. And so that makes more sense because you hit it general and then you go on more specific. You see what I'm saying? And so you don't depend on your specific case to make a general argument. You understand? Yes, ma'am.
When you're done, I can take a few pictures.
Sure, no problem. All right, so that is it for ethos. I don't know more of ethos. The next one.
That's just one?
That's just ethos.
Entry?
That what I'm saying. They ain't talk about logos yet. We ain't even start.
What?
Ain't even start logos yet.
They know you lying to me, man.
I'm serious, man.
All as I write, you mention that word yet?
We ain't mentioned logos yet. You see logos anywhere? We just on establishing our credibility. That's all. That's a very important.
It's
Establishing credibility
crazy.
first. Right? We ain't even start with the other things. Okay, so um
I can take the pictures before you forget.
okay, yeah, no problem. So yeah, I'm gonna end here. I'm not gonna push it. So next class we're gonna look at logos and pathos, and we also have to look at we also have to look at Tolman's model for Tolman's model for analyzing arguments and then recognizing a writer's tone. So that's what's in sequence for this week. And I think we'll just rumble on to next week because we took this long just to Ethos. So that's the lineup. Any questions before we go?
Mr. T, don't get a send a video, please.
Thank you so much. Right, let me do that. And then, so do we understand Ethos
Yes, sir.
and how it could be used?
Yeah.
Yeah. In the recording, is biology is inside that, right?
Bio
Mm-hmm.
Bio was no, bio is not a part of it. I separated them. So
Okay,
this one
but
is
you could
just a
send me.
4-hour one.
Okay, but you could send me bio when you're done, please.
I will send bio once bio is uploaded. I happen to do it
Okay.
tomorrow.
All right.
Sorry. All right, so have a wonderful night. See you tomorrow. God spare. Remember, even if the link is not sent, still come because we have classes this week.
All right. Good night. Thank you.
Good night. Night good. Take care.
I get the picture for the so.
No problem. I am blowing now. Who blowing kisses? What is that?